Good morning, students. Hope that by this time you have clearly understood what is SN1 reaction, SN2 reaction, and inversion of configuration, racemisation, chirality, asymmetric carbon, etc. Today, let's study what is retention. So consider a chemical reaction like this. So A, C, X, B. Four different substituents are attached to this carbon. Now, a nucleophile Y is going to attack this compound. Now let's see what happens. Here, the structure of the product, there's only one small change. In place of X, Y is there. Okay. Now consider another example. L levorotatory 2-methyl butane 1-ol when heated with the HCl. We are getting D form of 1-chloro-2-methyl butane along with the formation of water. Here also, in place of OH, we are having Cl. So actually this process, this is called retention of configuration. Retention of configuration can be defined as the preservation of integrity of the spatial arrangement of bonds to an asymmetric center during a chemical reaction. So generally speaking, so look at these two reactions. I'm explaining the concept once again. If generally when we are speaking about a particular reaction, no bond to the stereo center is broken, the product will be having the same configuration of groups around the stereo center as that of the reactant. So in such a case, we can say that it is proceeding with the retention of configuration. Now, let's see what is inversion, retention, and racemisation at a glance. So consider this compound. Consider this reaction first, and then this reaction, and consider this third. In the first case, what is the change happened here? In place of X, Y came. So obviously, we can say that in the case of A, retention of configuration has happened, and moreover, this is an optically active compound. Now consider the second stage. Here, in place of X, Y has come, but see the position of X and see the position of Y. Let's call this particular compound or the product as B. Here obviously we know this is an optically active compound. Here what happens? Inversion of configuration has happened. Okay. Now consider this, the third. If we are getting a 50-50% mixture of A and B, we can say racemisation has happened, and obviously we know in the case of racemisation it will be optically inactive. So if A is the only one compound obtained, we can call this as retention of configuration, and if B is the only one compound obtained, we can say that this is inversion of configuration. And if this A plus B is formed, I mean a 50-50% mixture, if it is formed, we can say that racemisation has happened. Now let's have a quick glance of SN2 mechanism and SN1 mechanism. So we have seen that SN2 mechanism, in this case, inversion of configuration will be there in the case of SN2 mechanism. Now consider this reaction. L form of this 2-bromo octane when it is treated with a strong alkali, say sodium hydroxide. So sodium hydroxide, it dissociates to Na plus and OH minus. So OH minus, it is a nucleophile. What happens when it is going to attach or attack this particular compound? So see what happened. One bromine, this is broken, and a bromide ion that is formed to form D octane 2-ol. So here inversion of configuration has taken place. The nucleophile attach itself on the side opposite to the one where the halogen atom is present. Now let's see what is SN1 reaction. Consider this example: 2-bromobutane. So here carbon with a positive charge, so carbocation is formed. The carbocation formed in the slow step, being sp2 hybridized, is planar, or we can say this is achiral. The attack of a nucleophile may be accomplished from either side, resulting in a mixture of products, one having the same configuration and the other having opposite configuration. So consider this reaction. Nucleophile, in the first case, OH minus is going to attach to this carbocation, forming this product. The second case, this OH minus is going to attach here to form this product. So the compound is L-butane 2-ol. Here it is D form of butane 2-ol. So to sum up, we can say that SN2 reaction, inversion of configuration, and SN1 reaction, racemisation. Thank you.